This lesson will review the monadic action and some of the iterative functions to perform action on individual elements of a list. Let's start by refreshing your memory of the difference between pure expressions and action. Pure expressions are evaluated solely based on the values of their input arguments. They rely on no context and cause no side effects. Pure expressions are deterministic, meaning they consistently produce the same output for a given input. For example, when invoking the add function with 2 and 3, it will always evaluate to 5, regardless of how many times or when it is called. Its execution remains isolated within the function without affecting external variables or state. Action is a type class, which has various instances, such as update, script, optional, either, etc. Among the various instances, this lesson will focus on update and script, because they are the only types that lead to ledger actions or ledger events. For instance, optional is also a data type that happens to be an instance of action. However, optional evaluates to either some value or none. It does not evaluate to either update or script. Therefore, optional does not lead to a ledger action. Action in this lesson refers to the expressions that evaluate to either update or script. Unlike pure expressions, action expressions that evaluate to update or script rely on context, such as ledger state. They also have the effect of updating the ledger. Update directly leads to a ledger action, while script can lead to a command submission. The command submission then causes DAML to run on the ledger to generate an update, which then leads to the ledger actions. Use the do notation to compose an action. Use the left arrow notation to bind the result of the action on the right side to the variable on the left side. Using update and script, in addition to creating a contract and submitting a transaction to a ledger, you can also retrieve data from the ledger. All the functions on the left side return update, and the functions on the right side return script. Fetch, fetch by key, and lookup by key are used in a choice, which returns an update. All the query functions are used in a test script, since the return type of a test script is script. Let's try testing one of them, query. Here's a simple bank account template, which takes bank, account owner, and balance. Bank can exercise apply interest on a bank account contract to apply 5% of interest to the account. The test script has allocated 4 parties, bank, Alice, Bob, and Charlie. Each of Alice, Bob, and Charlie has an account with a balance of 100.0. Use the query function to query all the active bank account contracts that are visible to the bank party. It returns a script value containing the long list of tuples. If you want to have the bank party exercise apply interest on each one of the contract IDs, you would have to iterate through this list. You may have thought of using map, but it doesn't work in this scenario. Let's talk about why. In DAML, the map function takes a function and a list as arguments. The function provided to map should return a value of type B. If you map the show function over the list of 1, 2, 3, it evaluates to a list of text. In a test script, we can pass this list of text to debug. As a quick reminder, when you pass a value to debug, it prints the value and returns an empty action, which can be either an empty script or an empty update. In choice bodies, debug returns an empty update, while in test scripts, it returns an empty script. In both cases, debug prints the value and returns an empty action. As a result, when you provide the map expression, resulting in a list of text, to the debug function, it prints the list and returns an empty script, which is an action. However, when you map the debug function over the same list, you end up with a list of actions, not an action containing a list. This is a problem because inside a do block, you need each expression to either 1. Evaluate to an action, or 2. If it's a variable, it needs to be used in an action expression to ensure that it has an effect on the ledger. In other words, you need a way to convert this list of actions into a single action containing a list of results. To address this, you can use the map_a function instead of map. Map_a also takes a function and a list as arguments. The key difference is that map_a performs an action on each element of the input list, then it converts the list of actions to return a single action containing a list of results. The type constraint applicative M indicates that the value of type M in the signature must be an instance of the applicative type class. In DAML, the functor type class provides a way to apply a pure function to values wrapped in a context, such as list, script, update, optional, and so on. The applicative type class further extends this capability by enabling the application of one or more functions within a context to values within another context. Functions like map_a are considered effectful because they evaluate to an applicative effect of performing actions beyond pure computation, such as modifying the ledger. The action type class allows composing these effectful functions while keeping them encapsulated within a context. Let's take a look at some examples of using map_a. In the first example, map_a maps debug over the list 1, 2, 3. In the second example, map_a maps debug over the list of tuples representing the active bank account contracts. Both examples using map_a evaluate to an action containing a list of empty tuples, and debug prints the corresponding values. For this reason, you must use map_a to exercise apply interest choice on each of the contract IDs. By printing the allAccounts variable, you can see that it's a list of tuples. Each tuple contains contract ID as its first element and contract payload as its second element. You can use map_a by passing the lambda function, which takes each tuple element x, and have the bank party exercise apply interest choice on the first element of each tuple x. As a result, the map_a expression evaluates to a list of new contract IDs. You can confirm on the table view that all 3 of the old contracts were archived and 3 new contracts were created with increased balances. In addition to map_a, there are other iteratives that you can use for mapping actions over a list. There is for a, which is map_a with its arguments flipped. There are also map_a and for a with an underscore, in case you want to perform actions while you're not concerned with the results of evaluating the actions. There's also fold_la, which works similarly to the regular fold_l, except fold_la is used for performing actions. This lesson focused on the action type class. Update and script, which are instances of action, are different from pure expressions due to their context dependency. You can use actions to interact with a ledger. When you perform actions in an iterative, you can use action-specific iterative functions, such as map_a or for a, instead of regular iterative functions.